Good evening. So today we're gonna see introduction to MapReduce. So basically, in this model, we'll see that how to solve the problem. So we'll talk. It's a high level. Again, we're not going to deep dive into the intricacies of the MapReduce, but at the high level, what is MapReduce? What do we mean by map task, reduce task, and also we'll see that how do we actually solve the problems in a MapReduce paradigm. In other words, if you want to solve if you're solving a problem in MapReduce job, how do you basically need to think in terms of key value pair? Because entire MapReduce frameworks works only on a key value pair. Yeah. So in this module, we'll see what is a MapReduce job, then we'll see input split, and then we'll see what is mapper and reducer. MapReduce is a framework, and what kind of framework it is? It is a computation framework, right? It's a computation framework for processing the data residing on the HDFS. It's a computation framework processing the data residing on the HDFS. And how does the data resides on the HDFS? It is in the form of blocks. In the form of blocks. And also you need to understand, and also we have already know that MapReduce is known as a batch mode. And why it is a batch mode? Because though you are working on the blocks of data of a particular, since a file has been divided into blocks, so many small blocks of 64 MB or 120 MB, but you don't have the flexibility to access and analyze the individual blocks. So at any given point of time, you have to process all the blocks of data. Okay, so that's why it is known as a batch mode. And a MapReduce framework consists typically of 5 phases: a mapper, partitioner, sorting, shuffling, reduce. But as of now, it's sufficient to understand that a MapReduce job starts with your mapper phase and ends with his reduce task. Sorry, it starts with the map task and ends with reduce task. Okay, I would say it starts with a map task and ends with 0 or more reduce task. So a MapReduce job starts with map task and ends with 0 or more reduced task. Okay, so you can have a map reduced job with 0 reduced task. So that is known as a map only jobs. So map only jobs are those kinds of jobs where the number of reducer tasks is 0. Is 0. If someone asks you that can you have a 0 map tasks, then the answer should be no. You cannot have a map reduced job with 0 reduced task. Okay. Now, a single map task works typically on one block of data. A typically word, typically on one block of data. Before that, let's say if a data, let's say you want to work on a data which has been broken into 3 blocks, B1, B2, B3, assuming the block size is 64 MB. So the block size with which you have kept this file into HDFS is 64 MB. And you are running a MapReduce job on this data. So by default, actually the statement which is coming up, so by default, number of map tasks is equal to number of blocks, and number of reduced tasks is equal to 1. That's a default nature if you don't do any settings. That's so. In this case, if you're gonna run on this data set a MapReduce job, then number of map tasks will be equal to number of blocks, which is equal to 3, and number of reduced tasks will be equal to 1. Okay. The word typically. So basically, if you want to understand, as I've told you, all this B1, all this B1, B2, B3, they are of size 64 MB. So, what you can say, in other words, that each map task is processing how much amount of data? 64 MB of data. Each map task is processing 64 MB of data, right? So the word typically here, it means that you have the flexibility to change the amount of data that each map task is going to process. So that's the meaning of that, which we are going to understand when we'll talk about input split. But here the word typically means that you have the flexibility to change the amount of data that each map task is going to process. Okay. So now let us cover one by one whatever I have just explained. So that is the default nature, that number of map tasks to number of blocks, and by default each map tasks process a block of data, assuming that block of data is 64 MB. So as I've explained, each map task is going to process. The default nature is that each map task is going to process that block of data. The word typically, it means that amount of data that each map task is going to process, it can be changed. Okay, and then after all map tasks are completed, the output from the map is passed on to the machines where the reducer task is running, and the reducer tasks will generate the final output, and that will be stored on the HDFS. Will generate.
So
Yeah.
Uh, I have one question here. For example, in case we do in which the split size is less, suppose for 128 MB we have three mappers running. So is it do we get any benefit doing this kind of settings in which maybe more than one mapper work on a single block? Are there any use case for it?
Yes, of course, the map slots are there. So you have more number of map slots that can be occupied. Per machine has certain number of map slots and reduced slots. So if this machine has a 3 map slots, so and if you are only occupied one slot to process the map task, the 2 slots are not occupied, then you are wasting the computational power. So what you do here, if you change the, if you decrease the input split size, if you decrease the number of amount of data that each map task is going to process, you might occupy more number of map slots, which means that you are actually utilizing the entire capacity of a machine.
Yes, yes. Yes, so thanks so much.
Now you have a file here. You have a file size of 120 MB. So this file is of size 120 MB. The block size we are assuming 64 MB, and the replication factor is 3. So we know that this particular file will be broken into 2 blocks, and these replicas, since you have these 3 replicas, and we also know that the replicas are distributed across several machines. So this is the scenario. So I've just taken all our slave machines here. I have just done one slave machine on the in the bottom, so that for the reducer machine, basically for the reducer machine, to actually bring up the fact that the mapper outputs gets transferred to the network and goes to the reducer machine. So I have drawn it on the downside here. So all our slave machines here. Now here you have how many number of blocks you have? You have 2 blocks. and that's why number of map tasks is 2. You should not count the replicas because there is you it's does not make sense that you are running the map task on b1 also, running the map task on this b1 also, running the map task on this b1 also. There is no point, right? It's just a wastage of your power, computation power. So you say it's a 2 blocks of data, and hence the number of map tasks is 2. And each of these map tasks, you must understand, each map task is processing different blocks of data, and both of these map tasks are running on a separate JVM. Are running on separate JVM, and since they are running on a separate JVM, so they are qualified as an independent tasks. So these map tasks are independent tasks. And what do you mean by independent task? Failure of one task does not affect the execution of other tasks. And once the map task is completed, the output will be transferred to the machine where the task is running. And this map task is generating this output, output 1, output 2, and both this output goes to reducer machine, and the output here, it is actually a network. So what I'm trying to emphasize here is the output of the mapper task is transferred over the network and goes to the reducer machine. And the reducer machine works on the output of all the mapper tasks and generates the final output that is going to be saved onto the HDFS. Now, here, if you want, here again, I want to bring the fact that data localization is not applicable for the reducer task. Data localization concept is not applicable for the reducer task. Okay, because whenever there is a data transfer, then there is no concept of the data localization. Hence, that's why the reducer task data localization concept is not applicable to reducer task. It is applicable only for the mapper task. Now coming up, let's get familiarized with the few terminologies here. So, what do we mean by job? So, a job is a complete execution of the mapper and reducer task over the entire data set, and that's why it is known as a batch mode. So, as I've just explained you, let's say we assume a data with 3 blocks, and you run the MapReduce job on this data set. So by default, there will be 3 map tasks and 1 reduce task. So this is known as, so this 3 map tasks and 1 reduce task. So this is your one complete job. So complete execution of the mapper and reducer over the entire data set. So this is a one job. What is a task? So task is a single unit of execution. You have a map task, executes typically over a block of data, and the word typically we are going to understand very soon. But you should understand that the word typically here, it means that you have the flexibility to change the amount of data that each map task is going to process. So the default nature of the map task is it processes the entire block of data, and reducer tasks work on the mapper output. Fine. Now let us get familiar with the task attempt here. So the word itself says that attempt, the task attempt. Task is nothing but it's a map task. Either it's a map task or it's a reduced task, right? And either of these tasks is an attempt. The task attempt is basically the map task or reduced task attempts to execute the task successfully. So map, either it's a map task or reduced task attempts to execute the task successfully. When we are saying execute a task successfully, basically we mean that every time the task cannot be completed successfully, because there are n number of reasons a task can fail, because of machine failure, because of your data problem, or the logic which you have written in the map task to process the data, it has some problem, it has some bugs. So every time you cannot process the task successfully. That's why it's an attempt to execute the task. Okay. So if at any given point of time, if a certain task has failed, then you actually it will be it will be reattempted. So if a task has failed for some reason, then it will be reattempted. And there are four default attempts. Four attempts are there to execute the task. And if any of the task has failed four times, then irrespective of how many tasks it has completed successfully, entire job fails. And in that case, no output is generated. To understand this, so let me give you an example. To understand this scenario, let us talk about a uh, college student who is in, let's say, semester 2. Okay, and he has five subjects: mathematics 2, M2, network theory, electronic devices, some EMT, electrical, whatever. Some I'm just taking some few subjects, electrical. So in a semester 2, he has to clear all the five papers. Okay, and now let's say, so every time he has to go for an exam, right? He has to go for an exam center to give the exam, to perform the exam. And now exam center is like my cluster where I will execute my task. Exam is like a task. Okay. Now let's say he has, so I'm just assuming that he has given, I'm just bringing the fact that all this now exams are, let's say you give in a different amount, you don't give in one shot, right? You actually give in you give after one week duration interval. But to just to make an analogy, I'm taking that you have an M2 paper here, you have a network, you have a ED, you have an EMT, and you have electrical. So you consider these papers as a blocks of data: B1, B2, B3, B4, B5. So in this semester, you have to clear all the five or the map tasks. So you have a five blocks of data. So five map tasks are running. Now, when you go into examination center or when you are giving an examination, so your state of mind is to somehow clear the paper, right? You actually first try to get 35 marks, and then you thought of scoring more. So you actually attempt to clear the paper, but even a topper can fail in an examination because maybe he has not well prepared, maybe the questions were out of syllabus, or maybe his health is not supporting him, or maybe for some or the other reason, a topper can also fail in the examination, right? So once you fail in the examination, you know that if this is your mains exam, we say it's a mains, then you actually get a supplementary to clear. Second chance you get it supplementary to clear that same exam. Again, if you don't get the supplementary, you get actually some more attempt. Let's say in our college we used to get pre-mercy to clear that paper. Again, if I am not able to clear the pre-mercy, I get a mercy. So one, two, three, four attempts are there to clear one paper. And what happens then? Now, for example, in network I have scored 100 out of 100. Electronic devices I have scored 100 out of 100. EMT I have scored 100 out of 100. Electrical I have scored 100 out of 100. But this mathematics too, I have failed all the 4 times successfully. I was not able to clear the mains, I was not able to clear supplementary, I was not able to clear the pre-mercy, I was not able to clear the mercy. I have failed all the 4 attempts successfully, one after the other. So irrespective of how many papers I have cleared or either I have topped, does not matter, I get a year back. Or you have to repeat that semester, right? Similarly, what happens? Let's say you have cleared, you have successfully, this task has successfully processed this block of data. This task has successfully processed this block of data. This task has successfully processed this block of data. This task has successfully processed this block of data. But this task is processing and it has failed 4 times. Then, irrespective of how many tasks has been completed successfully, how many tasks has been completed successfully, doesn't matter, right? So even if one task, so doesn't matter if one task fails 4 times successfully, entire job fails, and no output is generated. Okay, so let us see diagrammatically now. So you have 2 blocks of data, 2 map tasks will be processed. This map task is running, this map task is running. These tasks are independent, and each of them processing different blocks of data. And assuming this task has completed and this task is still running. I hope you should understand these tasks are running, both of them are running parallelly and they are independent. Yeah, independent means that failure of one task will not affect the execution of that task. Now, this task has completed, this task is still running, and it has failed. Failure could be network failure, machine failure, a data problem, or the logic what you have written in the map function that has some problem and it has failed. So you get another attempt. So the framework will give another attempt to process that block of data. Again, if that task has failed, you will get another attempt to get to again attempt on to again to get another attempt to process that block of data. If that has also failed, at this point of time, 3 tasks has failed on the same machine. So in a multi-node scenario, the other attempt, that is the last and the final attempt, will be done on some other machine, just to make sure that it's not a machine problem, it's something else. So here you have the fourth, last and the final attempt. It's running here and it has also failed. So irrespective of, so it says that if any task fails by default 4 times, then entire job fails and no output is generated. So this attempt, number of attempts, you can change it by this property mapred.map.max attempts, mapred.reduce.attempt. The default values are 4. Okay, and now if speculative execution is on, then more task is gonna run. If you remember in the introduction module, I was actually saying this statement that the strength of the chain is determined by the weakest link. Now, similarly, if we are going to make an analogy with respect to the MapReduce framework, then the performance of a job is determined by the slowest running task. So if we have, let's say, 100 tasks are running parallel, T1, T2, T3 till T100, and out of this, the 99 tasks have taken 1 second to complete, and the T100 task has taken 1 hour. Then you don't say your efficiency of the job is 1 second, but you say the efficiency of job is 1 hour. So the efficiency of the job is determined by your slowest running task. is determined by slowest running tasks. And speculative execution is a feature to improve the efficiency of the job when few tasks are running slow. Now let me give you an example that how this speculative execution works. Now here let's assume that it's me and I have two friends with me, Vipin and Sajid. Okay, and now I suddenly have a work in a place, let's say in a place silk board, and in a silk board there is a place by Madiwala, and in Madiwala there is a shop by name, let's say X shop, and the rice in that shop is very good, and I wanted to buy a 10 kg of rice. So this Som guy has a job of getting 10 kg of rice. Okay, and we are staying at Marathalli. From Marathalli to Silk Board, it's a 13.5 kilometers, let's say, and I have a job of getting the 10 kg of rice. Now what I do is I give this job to Vipin. So Vipin, you have the job of getting the 10 kg of rice and from this particular shop, and now you started. So what you do, from bus stop you took a bus, and you know the traffics, right? So you actually went till here, till Belandur. Now you have called me, and then I give you a call. Vipin, where are you? So you say Belandur. Then again after 5 minutes, again I give you a call. You again told me that Belandur. Uh, after again 5, 10 minutes, again I give you a call, and then again you have said the same thing. What I will think is, boss, this Vipin is very slow guy. So I will mark you as a slow. So this guy is a slow. Okay, but I have another friend, Sajid. Then I don't have any other mechanism to find out that Sajid is a very fast guy and all. I will just anticipate, right? I will just speculate. I will just anticipate. I'll just imagine that Sajid might have a bike, might have a bicycle, might know some other shortcut, or might be a something, right? I just speculate, and I also give the same job to this guy. That Sajid, bring me a 10 kg of sugar. Now Sajid also starts. Both of them are also starting. And suddenly Sajid gives me a call that, and he is here. Okay, he has Vipin has reached here. Sajid actually reached here, and he gave me a call that saying that, now Som, I got your 10 kg of rice. Then what I will do? My job has been completed. I will say, Vipin, come back. So I'll say, don't now execute because my job is done. So you come back. So I will ask basically to kill this task. Okay. So this is how a speculative execution works. Now let us see in diagrammatically. So again, I have taken the same diagram wherein you have this scenario. We have two blocks of data. Two map tasks will be running. This map task is running, and this is also running. Both are independent, and this task has completed, but this task is still running because it is slow, and the slowness of the machine could be because of it's an older machine. The one of the reason that the task is running, it could be an older machine, it could be some of the other problem because of it the task is running slow. And how does you will come to a task is running slow is because of the progress report of the, because the task tracker. So in your case, the node manager will send the progress report, and based on this progress report, if um, if you receive the same progress report 3 to 4 times, then it assumes the task is running slow, and in that case, the framework will run the same task from some other block on the same block of data but on different machine, and these two tasks are running parallelly. So if any of the tasks, so if this task has completed first, or in other words, if any of the task has completed first, then the other task will be marked as skipped. Okay, so that task will be marked as a kill, and so that's basically so here I'm saying one of the task finishes first, the other task is killed and its output is rejected. So if this task is get killed and its output will be rejected, you might want to ask a question that if what will happen if both of the map tasks has completed together, then the one who sends the same heartbeat signal, the one who sends the first heartbeat signal or whose heartbeat signal is processed first, that output, that task's output will be taken, and the other one will be other task output will be rejected. Now we have introduced two kinds of tasks here. One, in the previous we have introduced a failed task, and you have killed task as well. And the difference between the failed task and the kill task, remember, it is because of some problem the tasks are failed, and these failed tasks will be reattempted by default 4 times. And this kill task, these tasks runs as a part of speculative executions and will not be reattempted. And will not be reattempted. Okay, let me just bring up my AWS machines and bring up my Ambari server, and then we'll so that we can do an hands-on on this map task just at a high level. Now let us cover the okay. Now let us see the input split. Now the word typically, if you remember, now that word typically will be, now you will understand the word typically. What I have told you, that number of by default, or the statement which I have made earlier was number of map tasks is equal to number of blocks. Okay, but now the real statement or the exact statement, whenever you want to use it henceforth, it should be the number of map tasks is equal to number of input splits. The number of input splits is determined by the input split size, and the default value of the input split size is the block size. So when the input split size is equal to the block size, then the number of input splits is equal to the number of blocks. So this statement will be still valid, and this will be valid when when input split size is equal to your block size. Okay, so input split is a reference to the data. Now remember, whenever you say reference is always referred to as your block of memory, 0 to 64 MB. So whenever you have a reference from a memory, then it's up to you whether you want to process the entire this block of data, or you want to process only half of the block of data, or you want it only to process 1/4, whatever it is. Okay, so by changing the input split size, you will see that you can change the number of input splits, which will change the number of map tasks. Now, and let us see, we'll take few cases to understand this. So here input split size, so I mean to say the file size 120 MB, it's the scenario I'm taking block size 64 MB. For the explanation purpose, I'm taking its replication factor as 1. So you have broken two blocks. Since replication factor is 1, you are replicating only once, and this is the scenario. Now here it's your case 1, wherein this is a case 1 where input split size is your equal to the block size, and the block size here it is 64 MB. So how many input splits will be there? 2, and hence the number of map tasks equal to 2. This is a default scenario, and or in other words you can say each map task is going to process 64 MB of data. If you want to, hello,
Yeah, so
yeah,
we are listening you.
okay. Now so I was explaining, so here um, so each map task is going to process 64 MB of data. So there are two blocks in two different machines, and each map task will take up the 64 MB of data. Okay, that's one scenario. Now the same scenario, but now without changing the block size. Please make sure we please understand here that we are not changing the block size. Block size remains the same. Okay, we are changing the input split size. So in this case, how many input splits will be there? It will be 4, right? So how it is 4? Actually, I actually see this is 64, this is 64, and he is asking about 32. So I can have two input splits from here. I can have two input splits from here. So there are 4 input splits, and hence you will see that there will be 4 map tasks. Each map task is going to process 32 MB of data. So in this case, each map task is going to process 32 MB of data. And if you want to see here, um, so the blocks remain the same, but now here you'll have two map tasks processing. Sorry, here map task is processing 32 MB of data, so you have a total of 4 map tasks. Now here in this case, input split size is 120 MB, or I can say it is greater than equal to your file size. It's a third case. And when I say what do I do? How many input split size? It will be 1, because I see it's a 64. It's a 64, so I can have only one input split size. If your file size is greater than equal to file size, even if it is 130 MB, it will be still be one input split. So each map task is going to, in this case, number of input splits is 1, number of map task is 1, and the map task is going to process 128 MB of data. Whatever the input split size, the map task will process that much amount of data. But here you see does not have a 120 MB block. So in this case, the data is going to be copied, and then it will make 128 MB block, and then single map task is going to process. So in this case, if you want to understand, this is a very typical case. You are not actually getting any parallelism, because all the blocks of data are going to go into are going to be processed by single machine or single map task. Sorry. So all the blocks of data is getting processed by single map task. Actually, you're not achieving any parallelism. If you want to actually frame this, what's happening, this entire in a words, if you want to frame this, it's like irrespective of how many blocks the file has been broken into, all the blocks of data is processed by single map task. In other words, you can say it's a single standalone Java application which is processing the entire data. Actually, these kinds of processing is useful in image processing or a face recognition. And also an important point I'm bringing up here, that don't you think the presence of replica would have avoided the data transfer, right? So having a less replica, having a more replica has its own advantages and disadvantages. Having more replica, and having less replica has its own advantages and disadvantages. Let me write it down later, and but before that, I will explain you that where this kind of processing can be useful, has its own advantages and disadvantages. So, for example, you are doing a face recognition. In fact, it's a clinical image where this person has has a cancer, and the cancer generally it occurs it affects the person's cheeks. It affects the person's cheeks, and it goes till your neck and everything. It goes till this. Okay, and the clinical images are very big images which are generally not compressed. And when you put this data onto Hadoop, when you put this actually data onto HDFS, it will be broken, right? It will be broken, replicated, and distributed, right? You know it. It will be broken, replicated, and distributed across several machines. Now, when it is broken, so it is there is a chances that, I mean to say, there is not a chance, because when the broken, so you actually get some B1 and B2. So B1 get some part of image, and let me just draw it like this so that it's clear. B1 gets some part of image, B2 gets some part of image, right? And now, if you want to actually see that how much of a cancer has really been affected, so you actually do a pixel by pixel analysis or processing. So in that case, you cannot process these two images independently and can come to a right conclusion. So in this case of scenario, you actually need the entire image to be processed together. So this is one of the scenario wherein this kind of framework, or this the case 3 is applicable.
So
Yeah.
actually, I have one question on this, like face, like image processing. So does it mean for all image processings, only one map should act on the entire
Yes.
this image?
Yes. For all the image processing, actually it is done until unless, see, if you want to do a face recognition, you actually have to process the entire image by one single map task. You cannot do it because the images, if you want to see 60% of the male's face, the down face below the nose, it's almost same. So
Yeah.
how do you actually do that? So that's why you need the entire face image.
Okay. Okay.
And the input split is controlled by these three properties: mapred.min.split.size, mapred.max.split.size, and the block size. This will always be a constant, because once you put the file onto HDFS, you cannot change it. So this is a constant. Whatever, this is constant. The reason why I am saying constant, because once you put the file on the HDFS, you cannot change the block size. And so that's why you can change only these two properties, and the values of these two properties, the default value is 1 byte. Here mapper.min.split.size, and the default value of the max split size is 2 raised to power 63, which is the longest value. It's a maximum value that a long variable in Java can take. In the formula here, it is that how do you actually change the input split size is maximum of minimum split size comma minimum of maximum split size comma block size. So here, minimum split size is your property mapred.min.split.size. Maximum split size is this property mapred.max.split.size. Now let us put the default values. Maximum of minimum split size is 1 byte, comma, minimum of maximum split size is 2 raised to power 63, which is very big value, and the block size is 64 MB. Maximum of 1 byte, comma, the minimum is 64 MB megabytes, and if you take the maximum, it is 64 MB. So the input split size is 64 MB default, by default, or I can say by default the input split size is equal to the block size. That's a very first hypothesis. So that's why when you run the map tasks, so number of map tasks will be equal to number of blocks. So very first hypothesis, it still holds good. Now for this case one, or let's say we'll go case by case. Case one we already know. It's a input split size. The default by default the input split size is equal to block size. Now case two is the 32 MB. I mean the input split size is 32 MB. So the formula which we have just seen is input split size equal to maximum of the minimum split size, comma, minimum of maximum split size. I cannot change the block size because once you put on the GFS, you cannot change the block size. So it is always be a constant 64 MB. And this is your input split size. Now, the input split size is 32 MB. So 32 MB is equal to maximum of minimum split size, comma, minimum of maximum question mark maximum split size 64 MB. What should be the values of those minimum maximum so that your left hand side and right hand side are equal? So 32 MB equal to maximum of, I can put let it be 1 byte, that's the default value of your minimum split size. Minimum of, I can put 32 MB, and that's your maximum split size as 32 MB, 64 MB. I'm going to do this maximum of 1 byte, comma, the minimum would be 32 MB and the maximum would be 32 MB. So in this case, if I want to achieve the input split size as 32 MB, what I have to do, I have to change the value of mapred.max.split.size to 32 MB. Now let us go back to the other case, the case 3. Here, the left hand side, so again, let me give the formula here. So you have input split size is equal to maximum of min split size, comma, minimum of max split size, comma, block size. Now input split size in this case is 120 MB equal to maximum of minimum split size, min split size, comma, minimum of max split size. Block size is as is constant, you cannot change it, so it is a constant 64 MB. Now in this case, what should be the values of your minimum and maximum split size so that your left hand side and right hand side are equal? 120 MB. So in this case, we can change the minimum split size to 120 MB, comma, minimum of maximum split size, let it be 2 raised to power 63, that's the default value, comma, 64 MB. Maximum of 120 MB, the minimum would be 64 MB here, and now the maximum would be 120 MB. So left hand side and right hand side are equal. So what you did here, you have changed the minimum split size to 120 MB in this case. The property it specifies is your MapRed dot min dot split dot size. So let us see. So let us see all these things in action first before proceeding further. Let me bring up the Ambari first. Colon 8080. Admin. Actions start all. Give me 1 minute. Okay. Get started. Okay. Okay, it has started. Now let us see here. We have Yan, and let us go to the active resource manager HA, and that shows up. Mhm. So right now we are what we are going to do is going to submit the job which we see here. Okay. So for that, what I did, I actually went into my this location, user HDP, and the current location, the version, and then I have actually searched for the examples jar here, and that actually gives me a couple of jars, Hadoop MapReduce examples jar, whatever. And what I want actually is, let me figure it out whether I can run this jar or not. Hadoop jar. Okay, I think I can run it. I would like to run the what count farm. Okay, but before I can do that, I have to um, let me bring up the chart. Just 1 minute. Okay, then let me first go to my Shakespeare in where we have our Shakespeare data. Let us first transfer our Shakespeare data to our cluster. Okay, I do have here uh, SCP SCP minus I Shakespeare .tar.gz ec2 hyphen user at colon home ec2 hyphen user. Okay, I have transferred. Let me go back to my machine. I should be able to see Shakespeare. Let me untar that first. rmanzlxf shakespeare.tar.gz. And let us put Hadoop fs minus put. Oh, I would not be able to put it because I actually have to create sudo su minus hdfs dfs minus mkdir uh, user. First, I have to create that for the EC2 user, EC2, right? And then HDFS, DFS minus change owner, EC2 hyphen user colon EC2 hyphen user EC2 user. I hope you guys are already comfortable with this because we have already performed this, right? And now I can Hadoop
Yes.
fs minus put Shakespeare to Shakespeare. So I'm putting my Shakespeare data um, onto
So
EC2 user. Yes.
So I have one question here. So right now we are putting the data from local file system into the HDFS. So this Hadoop FS is acting as a client, and it will would determine all the input splits and all that, right?
Yes, but why you are? I mean to say, are you confused there?
No, no. I mean, I'm just asking. So because it is the client who does all the input splits and all that, right? So that's it was just
The input split.
asking you.
Where is the input split concept coming up when you are doing the file operation? Do you remember whenever when I was doing the HDFS operation, did I ever introduce the term input split?
Oh, no, no. Yeah, sorry. So I got confused. Yeah, sorry. Actually, what I meant that it will break the data into the blocks. Sorry, I confused these two. Sorry.
Now it's under EC2 user. I have kept my Shakespeare data, and please see the block size as 120 MB right now. Right, this is a 120 MB. Now what I want to do is to run the MapReduce job on this data set. So if I'm going to run the MapReduce job on this data set, that is user on this what happened on this data set, how many map tasks it is gonna run? So we are going to run the MapReduce job on this data set. So by default, number of map tasks, as I've just told you, the number of map tasks is equal to number of blocks. Okay, number of reduced tasks as one. Now, comedy's file, the actual file size is 1.7 MB and the block size is 120 MB. So you have, let me add a one column here, number of blocks. So the number of blocks will be one here. Similarly, if you see the size of this glossary file and the block size, all will have one block size because the file size are very less here and the block size are very high. So the total number of blocks 1, 2, 3, 4, 5 is 5. So number of blocks is equal to 5. So when you run the MapReduce job on this data set, then number of map tasks will be equal to number of blocks, which is equal to 5. That is the first thing which we're gonna see. Let us do that. So don't worry about the command which I'm going to run. It's a simple command. I am actually under this, yes. And so I will say run the command Hadoop jar, this particular jar, Hadoop jar name, your word count, that's a program name because once you run this without any command line, so it will display all the programs that is associated with this particular jar, all these programs. So there are a lot of programs which you can see. You have aggregated word count, aggregated word histogram, BBP, DB count, and what I'm going to do here is I want to run this word count problem. So a MapReduce program that counts the words in the input file. I just want to run it. So don't worry how it is implemented. I just want to run it and I want to, whatever I have studied right now, I just want to verify that. But number of map tasks is equal to 5 or whatever we have studied. So we're gonna first verify that. Word count, which requires an input data. So if you again put word count, it will actually ask you, sorry, it's the spelling is wrong. So it actually requires the in lot of things you can give it. I will give only one input. Here it means that you can give lot of input and one output. I just want to give one input file, Shakespeare, and the output file is, let's say, the output directory name, the Shakespeare's input directory. The output directory name I'll say what count underscore output or OP1 and I run it. Okay, now I will go to the all applications and I'll just refresh the page to see that my job has got submitted. User is easy to user, word count, application type MapReduce, it is running container 6 and a lot of the stuff. We have not yet actually gone into our any of the things. I just wanted to make sure that we understand, we see all these things, right? Wait, just 1 minute. Okay, I can click on this. It has gone, it has completed. By the time I have clicked it, I can go to tracking URL history. And okay, so let me, I can see where is my history server. If you see here, can you see that? I went actually to MapReduce job history to see how many map tasks are running. So it confirms that number of map tasks are 5 and number of reduce tasks is 1. Is this clear? Is this clear?
Yes, so.
Yeah. Now that's a default.
Yes, so.
Yeah, that's a default nature which we have just understood. Now in this case, by default, each map task is processing 120 MB of data. Now what I want to do is I want that my map task should process. In this case, the map task should process only 1 MB of data, which means that the input split size should be equal to 1 MB, right? So the formula is input split size equal to 1 MB, which is equal to maximum of minimum split size, comma minimum of maximum split size, comma block size. The block size will be the constant, which is in this case it is 120 MB. So maximum of minimum split size. So what should be the values of minimum split size and the maximum split size, so that um, I should achieve 1 MB as my input split size. So let it be the default value of 1 byte, the minimum split size, comma minimum of maximum split size. I will make it as 1 MB, comma the block size. In this case, it is 120 MB, which is fixed constant. And when you do this calculation, you get maximum of 1 byte, comma minimum is 1 MB, and you get as maximum would be 1 MB, right? So you change the input split size to 1 MB by changing the maximum split size. Now in this case, when your input split size is 1 MB, when your input split size is 1 MB, how many map tasks it is gonna run? How many map tasks?
128 into 5, right?
How many map tasks it will run? So as you need to understand, as a block size is per file, as block size is per file, input split size is also per file. Now you have said that input split size is 1 MB. Is 1 MB is my input split size. How many input splits from here?
2. 128.
Two input splits from here, one input split from here, two input splits from here, one input splits from here, two input splits from here. Total of 8 input splits are there. So now when I run my MapReduce job with the input split size of 1 MB, you will see that number of map tasks will be equal to 8. minus d mapred dot max dot split dot size equal to 1048576. It is scribbling because the output directory already exists. I just need to give a different output directory name. You can always see number of input splits path as 8 here, which means that we're gonna run 8 map tasks. I have to define this. Let it finish, then I can see that, right? What happened here? Something has failed. Container ID, okay, it has successfully passed. That's fine. As soon as it has passed, number of map tasks as 8. Okay, fine. Now I hope this is clear, one part, right? Now let me put my Shakespeare with a block size of a different minus d okay, Hadoop fs minus d dfs dot block dot size equal to 1048576 minus put Shakespeare with a directory name shakes1. Let us go and see the block size. And you can see the block size is 1 MB here. Right, you can see the block size 1 MB. Now, what I'm going to do now is I want to run my MapReduce job on this data set. Now, you're going to run the MapReduce job. So, by default, the number of map tasks equal to number of blocks. Now, in this case, the block size is 1 MB. I will say number of num blocks as another column. So, 1.7 MB, it will have a 2 blocks. Here it will have 1 block. Here are 2 blocks, 1 block, 2 blocks. Total of 8 blocks. So when I run my MapReduce job, it will have total of 8 blocks. That means 8 map tasks should run. That's a default nature without changing anything. I'll change the output directory name and the input directory name. One, and also change this parameter. And I must see 8 map tasks. You can actually see here, I'm very sorry, shake 1, it is running 5. Okay, total input pass to process 5. That's fine. Shake 1, and it should actually run 8 map tasks. You can see that it has done 8 map tasks, right? You can see it from here. Now going back, now here you have verified that. Now my question has changed. Now my question is, I don't want my map task to process 1 MB of data. I want my each map task to process 64 MB of data. Map task should process 64 MB of data. Okay, which means that what I'm saying is my input split size should be equal to 64 MB. Now formula for the input split size of 64 formula for the input split size is maximum of minimum split size comma minimum of maximum split size comma block size, which is constant. In this case it is 1 MB the block size. Maximum of, now we can change the minimum split size to 64 MB. Let the maximum split size be 2 to the power 63, comma, the block size is constant, it is 1 MB, right? This is a constant block size. Now maximum of the 64 MB, the minimum would be 1 MB, and the maximum here it will yield 64 MB. So in this case, to achieve the maximum split size, to achieve the input split size of 64 MB, the minimum split size should be changed. Okay. Now, once you change the minimum input split size to 64 MB, the question is how many map tasks? As I've explained you, as the block size is per file, right? The block size is per file. The input split size is also per file. Now, let us say number of input splits as a column. We'll keep it here. Now, the block size, the input split size 64 MB. The file size is 1.7 MB. How many input splits you will have? You will have one input split. This is 57.59 KB and the input split size is 64 MB. How many input splits? You cannot break it. There can be only one input split. Similarly for 1.4 MB, right? And here you have total of 5 input splits. So hence 5 map tasks will run. Let us verify that. For that, let me just bring up calculator. What is 64 MB? It will be 64 into 1024 into 1024. That's 6710864. Okay. I'll change the output directory name to output 4, and this time I want to change my minimum split size. And the property here it is minus d mapred dot min dot split dot size equal to the 64 MB. And now let us see that it should run only 5 map tasks.
So,
Yeah.
just an observation, I can see the statement failing over to RM2. Is it because we have enabled the HA? Maybe
Yes.
RM1 is not reachable. It takes care of that automatically. I
Yeah.
was asking the same question yesterday.
Yes. Yes. exactly. Yeah.
Okay. Thanks. So
Yeah. And now you can see that the job has succeeded with 5 map tasks. So what we have seen is the what we have understood by this exercise is that you identify the number of blocks, you ran it without changing the input split size, and then you have seen that yes, it number of map tasks to number of blocks, and then you have the flexibility to change the input split size, and then that will change the number of input splits, which will change the number of map tasks. The word typically, which we have introduced as that that you have the flexibility to change the map tasks by changing the input split size. That those things we have seen in action. Okay. So that's all for today. In the next class, we'll continue with the uh, next portions, which is understanding the mapper task, how to solve the problems, or how to think in terms of key value pair to solve any map.